Here in session 77, we're going to also continue on with some more multiplication using polynomials. What we have here is we have x plus 6 being multiplied by 2x over 7. Now remember, when you have fractions, you can multiply numerators together and denominators together. In this case here, our x plus 6 is not written in the fraction form. How do we get it in the fraction form? By simply writing a 1 in the denominator. At this point now, we can multiply out. So I'm going to use the distributive property, take the 2x times this x, that's going to give us a 2x squared. Then I'm going to take the 2x times this plus 6, and that's going to give us a plus 12x. In the bottom, we're going to have 1 times 7, which is 7. 2x squared plus 12x over 7 is the correct answer. But you could also leave it in the factored form in the top. And in the factored form is where we had the 2x split apart. So we have the 2x here, then multiplied by the x plus the 6. Both of these forms are correct answers to the problem. Next, this one's a little bit more involved. What we have here is we could use the distributive property to perform this multiplication. We could go x over 5 times x over 4. We could then go x over 5 times 1 over x. Then we would take the 3 over x times the x over 4, and then the 3 over x times the 1 over x, and then we could go and approach it that way. But another method that we can use is to actually take each of these fractions within each of the parentheses and add them together first, combine them together. But in order to do that, we have to have like denominators. So what we're going to do is rewrite this first polynomial here, x over 5 plus 3 over x. And remember, we're going to take the denominator of our second and multiply it in the top and bottom here. So x times the x is going to be x squared. That's going to be our top. Our bottom is going to be x times the 5x. So x over 5 has now been rewritten as an equivalent fraction of x squared over 5x. And then what we're going to do is add to it the 3 over x, and to get that into an equivalent denominator, we have to multiply by 5 in the top and bottom. So 5 times 3 is 15. Multiply the top by 5, got to multiply the bottom by 5. 5 times x would be 5x. So we now have two fractions that have the same denominator. So we're going to combine our numerators together. That's going to give us x squared plus 15. And then our denominator is going to be 5x. So we've taken care of our first polynomial by combining the fractions together. We're going to do the same thing to our second polynomial. Here's our denominator, x. We're going to multiply top and bottom of our first fraction by x. So that's going to give us x squared on the top and 4x on the bottom. Now for our second term, we're going to multiply 4, our first denominator here, times top and bottom. 4 times 1, we'll get our plus sign out here, is a 4. And then on the bottom, 4 times x would be 4x. So x over 4 plus 1 over x has now been rewritten. X over 4 has been rewritten as x squared over 4x. 1 over x has been rewritten as an equivalent fraction of 4 over 4x. We have the same denominator now, 4x. So we can now combine our numerators together, our x squared plus 4. And then on the bottom, we have our 4x. At this point now, we can go ahead and use our distributive property to go ahead and calculate this out. X squared times x squared is going to be x to the 4th. X squared times a positive 4 is going to be a plus 4x squared. Now we get our second term. 15 times x squared is going to be a plus 15x squared. And then our last 15 times 4 is going to be plus 60. That takes care of our numerator. Now we come to the denominator. 5x times 4x is 20x squared. And after we perform this multiplication here, the last thing we want to do is see if there's any common factors that we can factor out. Well, in the top, our first three terms have an x in it, whether it be an x squared or x to the fourth, but the 60 does not, so we cannot factor out an x. And if we take a look at each of our coefficients, we have 60, 15, and 4, but our coefficient here is 1. So there's no coefficient that we can factor out as well. So this is, in fact, in its lowest terms. X to the fourth plus 4x squared plus 15x squared plus 60 over 2x squared. And actually, I just caught something there. We actually have two terms that are both to the degree of 2, so we can actually combine those together. But it won't help us in factoring anything else out, but we do need to combine those like terms together. So the 4x squared plus the 15x squared brings us up to a 19x squared. And then I'll just rewrite the 20x squared here on the bottom. So then quickly, when you're multiplying polynomials together, each that have two or more terms, you may use the distributive property to perform the multiplication. Another method that you can use, especially if your polynomials contain fractions, is to add the fractions of the polynomials together, or if it's subtracted, you would subtract them and then proceed on to multiplying the polynomials together. And that's in fact what we just did on the previous screen. That wraps up then session 77.